Everyone, and welcome to my YouTube channel. So here today we are going to be looking at redox reactions. So redox reactions are just reactions that involve both oxidation and reduction. Now when we look at our redox reaction, it might be defined in terms of oxygen, hydrogen, and the oxidation state. Now let's look at it from the perspective of oxidation in terms of oxygen. So firstly, oxidation is the addition of oxygen to a substance. So as long as you are adding a substance, then that is what we are going to call oxidation. For example, if we add, let's say, magnesium, we add oxygen, we are going to get magnesium oxide. So this is oxidation because oxidation is the addition of oxygen. So in terms of oxygen, oxidation is the addition of oxygen. So it is as simple as that. So this is how we define oxidation in terms of oxygen. So as you can see, as long as this is an oxidation reaction, since oxygen has been added to magnesium, then it's oxidation. Let's take this one. If iron 1 oxide reacts with oxygen, what is formed is iron 3 oxide. So this one, you can see that oxygen has been donated, taken to that. From here, it has been added for you to have 3 oxygens there. So this is oxidation in the fact that oxygen has been added like that. Now, oxidation in terms of hydrogen is different. It is the other way around. So oxidation in terms of hydrogen is the removal of oxygen. Remember, for oxidation in terms of oxygen, we are adding oxygen, but oxidation in terms of hydrogen, it is the removal of oxygen. So as long as we have the removal of hydrogen, then that is what we are going to call oxidation. Let's take this one as our example. So let's say we have ammonia, then it breaks down to form nitrogen and hydrogen like that. So this reaction is oxidation since hydrogen has been removed. So we can say this is oxidation since the hydrogen that is here has been removed. So that means it has been removed from nitrogen. That means to say that's oxidation. Let's take this other equation. Let's say we have this compound. Now this one is oxidation in the sense that we had 2 hydrogens bonded with sulfur. Now we only have 1. So since hydrogen has been removed from this, it means to say that's oxidation. So now this is oxidation since hydrogen has been removed. So as long as you remove your hydrogen, it means to say that's oxidation. Oxidation can also be described in terms of electrons, that is the charge. So we use the simple mnemonic, which is our rig oil. So oxidation is loss. That's the meaning of the initials. So we say oxidation is loss. Then when we look at reduction is gain. So gain, this one stands for loss. So oxidation is loss, reduction is gain. So now, just as we have said, the mnemonic stands for reduction is gain, oxidation is loss of electrons. So now let's dive deeper into this. Let's say we have this reaction, copper becoming into an ion plus an electron like that. So as long as electrons are on this side, which is the right hand side, that means to say those electrons have been lost. So as long as they are on this side, it means to say the electrons have been lost like that. Therefore, this one is oxidation in the sense that electrons have been lost. So as you can see, as long as the electrons have been lost, that means to say it's oxidation. So using our mnemonic, which is oil, oxidation is loss of electrons. So electrons are lost. So you will realize to say metals tend to lose electrons to become like that. So that is oxidation in terms of electrons lost or gained. So oxidation is the loss. Let's take this reaction. So let's say aluminium becomes Al3 plus and 3 electrons like that. Then we have something like this. So this one is also oxidation since electrons have been lost. So as long as you have on the right hand side, that means to say electrons have been lost. Let's take this other equation. If you have chloride ion will become chlorine if it loses electrons. Now take note, nonmetals tends to gain electrons, but since this already has got electrons, it means to say for it to go back to its original state, it needs to lose the excess electrons. So that's why we have electrons lost here. So that's the way it is. So if it is Cl negative, it means to say it has got more electrons. So in order for it to go back, it needs to lose those excess electrons. So this is oxidation in the sense that electrons have been lost. Let's look at reduction. So reduction in terms of oxygen. So reduction is the loss of oxygen. So that is reduction, or rather it is the removal of oxygen. So as long as oxygen has been removed, that means to say it is reduction. So let's take this example. If we have a reaction where carbon dioxide reacts with carbon to produce carbon monoxide, you will realize to say the state of carbon dioxide was a 2 here, combines with carbon, then we only have a 1 here. So that means to say this is a reduction in the sense that oxygen has been removed. So as long as oxygen has been removed, that simply means to say that's reduction. So the reduction is the removal of oxygen. So we can say carbon dioxide is removed since oxygen has been has been reduced. So carbon dioxide is reduced to carbon monoxide since oxygen has been removed. Let's take this other equation. Let's say we have lead oxide reacts with hydrogen to produce lead plus water. So now this one is oxidation since it's reduction since oxygen has been removed from there, but at the same time it's oxidation on the part for hydrogen. So you need to be careful, though we are going to dive deeper into this. Now this is oxidation, this is reduction. So we can say lead oxide has been reduced since oxygen has been removed. So it is reduced. So this is reduced since oxygen has been removed, like that. Reduction in terms of hydrogen, on the other hand, it is the addition of hydrogen. So as long as hydrogen has been added, then that means to say that reaction is reduction. So that is a reduction reaction. So it is the addition of hydrogen. So that is what we mean. Then what we are going to have is, let's take this example. We have nitrogen reacting with hydrogen to produce ammonia. So this one is reduction in the sense that hydrogen has been added to nitrogen. So we could have such a thing where the hydrogen has been added like that, then that is reduction. So reduction is the addition of hydrogen. So we can say nitrogen is reduced to become ammonia since hydrogen has been added. So as long as hydrogen is added, then that means to say it is reduction. Let's look at this other equation. We might have ethene. So ethene reacts with hydrogen to form what we are going to call ethane. So now the main thing is that we have hydrogen, we have 4 hydrogens here. It has now 6 hydrogens. Since hydrogen has been added, we can say that this is reduction. or rather ethene has been reduced to ethane since hydrogen has been added, like that. So we would say it is reduction since hydrogen has been added. So that is what we refer to as reduction. The reduction in terms of electrons gained or lost. Reduction is gain. Remember our mnemonic, reduction is gain. So as long as there is the gaining of electrons, then that is called reduction. So now, the example that we might, so let's take this as our example. If copper 2 ion, this one 2 plus shows or indicates that it has got it has lost electrons. So in order for it to go back to its normal state, it needs to gain electrons. So now when it gains electrons, it will become copper. Now when you put your electrons this side, it means to say the electrons are added to produce copper, like that. So this is reduction since electrons have been added. So you can think of it like that. So as long as electrons are added, then that simply means to say that is what we refer to as reduction. So the addition of electrons is called reduction. Now this makes sense because already, as you can see, the number here is 2. The final number, as long as it doesn't show, it means to say the oxidation state there is 0. So reduction, it means to say even in terms of the oxidation number, it is reduced. So the number goes down. For oxidation, the number goes up. So from 2 to 0, like that. Let's look at this equation. Chlorine reacts with, or rather, it combines or gains. It gains 2 electrons. Since electrons have been added, then that's reduction. As simple as that. Let's take this equation. So if we have iron 3 oxide reacts with aluminium to produce aluminium oxide, then what we have is plus ion there. So already, as you can see, on this part, since the oxygen has been removed, it simply means to say it is reduction. On the other part, since oxygen has been added to aluminium, this is what we are going to call oxidation. So that's why they are called redox reaction, because both of the reaction, reduction and oxidation, are taking place. That is the reason why it's called redox. So reduction, oxidation at the same time, like that. If we look at this equation, we have this. We can say that this is reduced since oxygen has been removed. Then this other one is oxidized since we have oxygen has been added. So this is oxidation, like that. So this is how redox reactions are written. So that's the way it goes. So let's say we have which of the following reactions is oxidation and which one is reduction. So you can just pause the video and try out. So to begin with, since electrons have been added, this is reduction. So on this side, it means to say it's reduction. When we look at this one, so this one is reduction. When we look at this one, electrons have been added, so this is reduction, like that. Then when we look at this other one, we have oxygen ion becomes oxygen plus 2 electrons. This side, it means to say electrons have been lost, so this is oxidation. Since oxidation is the loss of electrons, here also electron has been lost. This means to say it's oxidation. You can also tell by the number. If the number goes up from 2 to 3, that means to say it is oxidation. Even here, it is from -2, it has become 0. 0 is greater, so therefore it means to say it is oxidation. But you can just check out the number of electrons, like that. When you also look at this one, electrons have been added. It means to say this is reduction. So you can even see from +1 to 0. 0 is smaller, so that's reduction in terms of the oxidation number. Let's look at this one. State whether the underlying substance has been oxidized or reduced. So from carbon dioxide to carbon monoxide, it has been reduced since oxygen has been removed. If we look at this other one, the underlying is aluminium. Aluminium oxygen has been added, therefore it is oxidation. It is oxidized rather. When we look at copper, we also have aluminium. We also have ammonia and copper 2 oxide. It has become, so this one has become, so as you can see, ammonia, hydrogen has been removed, therefore we shall call it oxidation. So that is some of the ways that we can be able to identify which one, if it is oxidized or reduced. So in the next video, there will be practice problems that will be involving the identifying of redox, or identifying of the reducing agent and the oxidizing agent, and also calculations on redox reactions. See you in the next tutorial. Thank you very much. Hope you would like, subscribe, and share for more.